Hello viewers, welcome back. Next problem is given by the open loop transfer function of a unity feedback system is g of s equals to 4 by s into s plus 1. Determine the nature of response. The nature of response we have to calculate of the closed loop system for a unit step input. Also determine the rise time, peak overshoot and settling time. So this is the problem given. So in this open loop transfer function is given, feedback is unity feedback, and nature of the response for this closed loop system we have to find out. So closed loop system means always we will find c of s by r of s equals to g of s by 1 plus g of s into h of s. Why I am taking 1 plus means there is 1 plus or minus g of s h of s, but I will take 1 plus always. If nothing information is given about the feedback is negative or positive, we should always take it as a negative feedback only. Why? Because the most common feedback is negative. So we will take for negative value of feedback, it will be 1 plus. So that is equals to g of s is given, that is 4 by s into s plus 1 by 1 plus 4 by s into s plus 1 into unity feedback. So 1 it is. So simplifying this we get 4 by s into s plus 1 by s square plus s plus 4 by s into s plus 1. These two gets cancelled and we get 4 by s square plus s plus 4. This is c of s by r of s. From this, if we compare this with respect to omega n by s square plus 2 zeta omega ns plus omega n square, second order common transfer function. So omega n square is compared with 4, that is omega n square equals to 4 and omega n equals to 2, and 2 zeta omega n is equals to 1, so that is 2 zeta omega n equals to 1. Already we know omega n value, and zeta equals to 1 by 4, that is 0.25. So the nature of the response of the closed loop system always depends upon the value of this zeta. If zeta is less than 1, then it is said to be underdamped response. This is underdamped response. If zeta is greater than 1, it is overdamped. Zeta equals to 1, it is critical damped. Zeta equals 0, it is undamped. So this is zeta is less than 1 value. So the response for this problem is underdamped response. Next, ask to find rise time, peak overshoot and settling time. First we will see rise time. So rise time means TR equals to pi minus theta by omega d. That is equation for rise time. So now from this, theta equals to tan inverse of 1 minus zeta square by zeta. This is the equation for theta angle. So if we substitute values of zeta, tan inverse of square root of 1 minus 0.25 square by 0.25, we will get the value of theta as 1.3 radians. And next again we will calculate the value of omega d. Omega d equals to equation omega n into square root of 1 minus zeta square. Omega n is 2, square root of 1 minus zeta square is 0.25 square. So that is we will get 1.936 radian per second. So if we substitute these two values in rise time equation, we will get the value of rise time, that is TR equals to 3.141 is the pi value minus 1.31 is theta value by 1.936 is omega d. So finally we will get the value of this rise time is 0.945 seconds. Next we'll calculate peak time. Peak time equals to pi by omega d. So pi by omega d value already we have calculated 1.936, that is overall value 1.622 seconds. Next we'll calculate peak overshoot. So peak overshoot equals to exponential power minus pi zeta by square root of 1 minus zeta square. This is the equation for peak overshoot, and if we substitute zeta value in this, we will get the overall value as peak overshoot is 0.4326. Next, we will calculate settling time. So settling time TS equals to 4 by zeta omega n for plus or minus 2% tolerance. 4 by 0.25 zeta value into 2. So we will get the value of settling time as 8 seconds. Right? So these are time domain specifications values.